We're recording. Test, 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 test. Okay. Coming to you live. Welcome to Calculus and the PMs. I'm your host, Mr. Shindell. Implicit differentiation. First of all, what does the word implicit mean, non-mathematical, if you were to use it in Ms. Clark's class or something? Not directly stated. It's kind of hidden in there. Implicitly stating your thesis in your first paragraph is the opposite of explicitly stating. Explicitly stating something, it would be like, it is the purpose of this paper to show you that Hamlet was, that's explicit, right? Implicit is sort of within. Sometimes you got to read between the lines. Well, implicit, you'll see sort of an analogy here. Now, first of all, operators. What are some mathematical operators from grade 5? If I say the word grade 5 operators, what are you guys thinking? Do you guys even think of operators? Okay, I couldn't understand you. What's that? Operator. What's wrong? Yeah, dial disconnection all night long. Anyways, operator said, number's been disconnected. Operators? Okay, you guys, the word, you don't use it too much in math. This is an operator. Tells you to divide two numbers, right? Okay, you guys get the idea now, right? Operators, multiply. Sometimes, square root. Those are operators. Just jot those down because we're going to use the word sometimes. Use this operator, use the d by dx operator. And this operator here tells you to take the derivative of an expression with respect to x. Now, I don't have anything beside it right now. But this shouldn't be too difficult. I'm just getting you used to the idea of d by dx means. Usually we'd say dy by dx because we had previously defined what y was. So for example, if I said y is equal to 2x to the 11, and I said do the derivative of the y expression with respect to x, dy by dx, you would tell me it's 22x to the 10, correct? Skip the middle, man. You see how this works? Instead of saying dy by dx, I haven't defined this 2x to the 11 as y. I'm just saying do the derivative of 2x to the 11. And you'd say, well, that's 22x to the 10. And that's it. Yeah? Okay. That's the operator. Now, chain rule a bit. Apply the chain rule to this expression here. What do you notice, though, about this? Here, the variable matched with respect to the derivative with respect to the variable x. 6y, and I'm doing d by dx here. Rubbish. What are we going to do? Move on. Well, think of it this way. Just think of an expression here. And I'll just do this, I guess, in green just above it. What if I said, I'll make it really simple. What if y was equal to x? What would it be? The derivative of that. That'd be just 1, right? You guys follow that? So what if you imagine, and I'm going to erase this after, so I'll do it and disappear now. What if this was 6x? You just say the derivative of 6, right? Okay. We don't know what this is, though. This y expression there. Just that if it's a function of x, we'd have to take care of it. So what I'm going to do, I was working on it before. Okay. I'm going to say, well, the derivative is 6 times, because that 6 is out in front, times whatever the derivative of the y expression would be. Does that make sense? We'd have to do the derivative of the inside, or the y expression. Y expression could be x squared plus 5. It could be x. Okay. So we just say, well, the derivative of the y expression. Until you find out anything further, that the y expression is something else, that's all you can say. This is really the chain rule, in a sense, like it's the derivative of whatever that inside is. Remember how we defined the chain rule a bit with that u, let u equal the x expression? This is kind of like this. Okay. So think of y as like an inside function, because if it's a function of x. We'll leave that. How about this next one then? Doing it like that. Now think of this -2 expression here when you do it. -2 something to the 5, really, right? This is what I mean by, think of it as the chain rule. What is the derivative of that expression in C then? -10.
So, yeah, in brackets, dy over dx.
Wouldn't you leave the inside alone though? Not change it?
Oh.
Still y, right? If y represents x plus 5, you'd still have x plus 5. So y, it is confusing. Then you'd take the derivative of the y expression after. Does that make sense to you? dy by dx. He says yes, but nobody else. You said yes. Think of it like the chain rule. Take the derivative of the whole expression. In a sense, some people think of it as if the variable matched. 6y's derivative is 6. And then do the derivative of the y expression, if you can. Do the derivative like it was an x kind of thing, maybe, and then do the derivative of the y expression. Or write it down. Okay. Let's move it along unless there's a question. Apply this operator to both sides of the equation. Now this is something you would have done a long time. Like, if we say y is equal to x squared, let's apply this operator to both sides. I'm going to write it out this time. You wouldn't normally do this, but. So I'm saying apply to both sides. So d by dx of the y expression equals d by dx of the x squared portion. Y'all with me? You'd never do it this way, though. You would have skipped right to, and what is this? The left side? 1 dy by dx. You just write dy by dx. And you have been doing that, haven't you? All through chapter 3. You see why you put dy by dx when you do the derivative. So, then 2x. It's a match, x and x match. dx and x squared. So what I'm building on is this is nothing new, the first one. Now, this is a variation of that expression, right? I squared both sides. It means something different though, but not a lot different. Let's just see what this is. Maybe I'll move this over a bit. Take the derivative of the left, take the derivative of the right. Oh, not dy. d by dx of the y squared expression equals d by dx of the x to the 4 portion of the expression. And then solve for the derivative. Well, tell me what the left side is, tell me what the right side is. I'll give you a minute to think of it and write it down. Look above if you can't remember what to do with these y's. What do we got here? Try, Stan.
I know the right side.
Okay, the right side is better than nothing. I'll give you 0.5 out of 3. Okay.
Thanks. What we have first.
I didn't think you guys would have a problem with that side. What about the left side? You do the derivative of the outer function, you think of it as the chain rule. Y represents something. 2y, and then dy by dx. Okay. Okay. I've got it. Can you isolate now for dy by dx using algebra? Think of dy by dx as one chunk or one thing. You can't, it's not a fraction. Don't separate. Keep this here, and then the rest divide by 2y, right? Both sides. Is equal to 4x cubed divided by 2y. So I'm going to do the 4 divided by 2. 2x cubed with a y expression. Oh yeah. And how? And then some. Okay. It's okay to have y in some of your derivatives. And if you're told what y equals, you could sub it back in sometimes, too. Like in this particular case, if I told you that y equals x squared, then you could sub that in here and you just have x squared underneath 2x. Hey, it'd be the same thing. That's designed that way, though. But I didn't say that for sure, but that's what it is. Now, do you guys know what kind of equation this is? It's not a function. What shape would you get if you graphed that, though? That expression, that relation? You guys saw it a bit, but you didn't use it a lot in pre-calc 30. Circles. You graph x squared plus y squared equals 25. Hey, 25 is the radius squared, by the way. You guys recall x squared plus y squared equals r squared? Equation of the circle? Now, Shane, you're saying yes, but everybody else says no.
I like to call like what no one.
You think you recall graphing circles and stuff like that with centered? No? Okay.
We did like unit circles. Yeah.
Unit circle, sine squared plus cos squared equals 1. Unit circle, the radius squared is 1. Okay. But then there's a unit, whatever, you guys don't know. You didn't do that unit. Okay. It's okay. I'm just making sure. That's cool. Derivative using implicit differentiation. Do the derivative of the left, do the derivative of the right. Now, before I actually had you write out d by dx in front of everything.
Can you graph that on the calculator?
No, you couldn't graph it because your calculator has to have y equals. So you'd have to isolate for y first. There might be a way, like you can subtract 25 minus x squared, take the square root, it would be the positive portion, which would be this half of the circle, and then the negative portion as y2. And then you'd have your circle with a radius of 5.
Should we just move everything to
Pardon?
move everything to the right side?
And take the square root to solve for that. But don't worry about it right now. We'll just do strictly the calculus on this. So, let's do the derivative of the left side and the right side. So if you're going to, not that I suggest you actually rewrite this here, but do it of this side and then do the derivative of that side too. I can't squeeze that in there, but it's going to disappear. What's the derivative of the left side though? Do the x squared portion first, and it is? This is the simple one, 2x, right? I was saying I wasn't going to do that, so I won't. 2x. I was going to put up. 2x, there we go. Plus, what's the derivative of 2y, or y squared, but d by dx of y squared? 2y dy by dx equals derivative of 25. 0. It doesn't matter what the variable is, it's 0. So, I can isolate, I'll do it in 2 steps here. 2y dy by dx. You're getting dy by dx alone using algebra. And dy by dx is equal to negative 2 divided by 2 is negative 1, x over y. What does that mean? Now, you don't have to be familiar with this graph of a circle, but I'll just jot it down. Don't plot it carefully, but this is 5 here, and this is 5 here, etc. We have a derivative. And a derivative, what's an explanation or description of a derivative? It is a
Equation for the function of the tangent line.
equation for the function.
No,
Slope
slope.
of a tangent line to a given function. Yeah, okay. I'll be reading those carefully, especially yours. This tells me any point on this circle. Anywhere. As long as I know what the x and the y coordinates are, I can find the slope of this tangent line right here. Well, here's an easy one, 0, comma 5. If I put 0, comma 5 in here, I got negative 0 over 5, it's 0. That makes sense, the tangent line has a slope of 0. Right here, does this make sense? 5, comma 0, yeah, 5 over 0. Yeah, I knew it was going to do that. Infinite, right? Undefined. Okay. But anywhere else, if you come up with a set of ordered pairs, it works, right? And you can have the slope over here, over there, wherever. Slope of those tangent lines as long as you have an x and a y from that expression. I won't even get into what this might be. But we're going to just operate this. Sometimes it doesn't even matter what they geometrically would graph like. But let's do the derivative of the left. The right is easy, right? It's 0. So 2x. Actually, I'm going to write this one out with d, and I'll show you why. So I'm going to put this in front of everything. d by dx at the x squared portion minus, and here's why, because this is going to involve the product rule, and people miss this all the time. I was going to put the 4 in front of the dy by dx, and that's the way I think of it, but I'm not going to show it that way, because most people don't when you're students. So I'll do it this way. Okay. Do write it out this time, because you're in learning phase. And you will miss something if you don't do this correctly. The most common mistake is on this one. Okay. Y'all with me? Pay attention. Derivative first expression is 2x, right? Minus. I mentioned it already. But think of this as the product 4x times y, okay? That means we have to do a product rule. I've got the minus sign out here, but because I'm using rule, I'm going to use a bracket here, okay? So the product rule is derivative of the first part of the expression, so the derivative of 4x is 4. Leave the second part alone. The y is left alone. Add that to the first thing left alone, 4x. Everybody agreed? The derivative of y would be dy by dx. Number of ways people screw that one up, and I don't like teaching mistakes, but I'm going to point something out. I taught you the right way. People often miss that it's a product rule altogether. And then if they try the product rule, they forget to put this bracket on, because in this case, you have to distribute the negative sign to each, right? If it was plus here at the start, you'd have no consequences for your misbehavior. But pretty hefty consequences to pay otherwise. Adulterous, terrible. Don't do it. 2y dy by dx. 0. We're all good with this? Is there questions about that step? The rest is algebra. We're going to isolate for dy by dx. We good? No question about this product rule step here? Okay. I'm keeping everything with a dy by dx, so this part and this part on the left side. I'm going to move the other stuff to the right. So in my mind, I'm going to distribute this minus and minus, right? Double, okay. So I'm left with, and I was going to skip another step, but I won't. Minus 4x dy by dx plus 2y dy by dx. I'm going to yank that over a bit. Again, and I like it. And then I am going to add 4y to the other side and subtract 2x to the other side. Oh, every time I use that magic pen, I feel I'm holding a pen. Tragic results. Regrettable. Okay. No mysteries yet? Nobody? What do we do now? Do you have something in common on the left side? Well, the dy by dx. By design, we have a common factor of dy by dx. I'm going to leave there's a common factor of 2 as well, but I'll leave that for now. We can take it out. So right now, I'm going to say I'm going to remove the common factor. This is what I was going to do all in one step. If you've done them a few times, you'll see what I mean. So dy by dx. Oh. This again. Then I'll isolate for dy by dx. You will. So I'm taking it and I'm showing a lot of steps. Get to the point though where you can maybe do, of those previous 3 steps, try to do it at least in 2 steps. Eventually. I'm not saying right away. So I think you can see all you do is divide the 2 expressions, right? 4y minus 2x over negative 4x plus 2y. Now, I mentioned before, there's a common factor of 2 in each expression, actually. So, I'll show it in 2 steps. 2y minus x. And I can take out 2. Does it hurt your feelings if I reverse the order on the bottom, just so I have a positive first, y minus 2x? If you want to have minus 2x plus y, that's perfectly valid. But there you go, and I think you see what happens next. Right? That's simplified. So there's a bit of algebra again, isolating. Now, forget what I budgeted for this one. I think it's 2 classes, though. Yeah. Oh, heck yeah. We're good on this. So, I'm going to get you guys to try the 1 through 13 odds, I think it was. Maybe even 17AB. We'll see. I'll just see what that was. Pretty sure. By the way, normals to a curve are at 90 degrees, but you don't have to do the normal for 17B, just 17A, I think. But 1 through 13, I'm looking. Odds. Oh, those are dandies. You'll love them. Okay, so just start up on these. Okay, give her beans. You got 20 minutes, 19 minutes right now, so I do expect you to not close it up. I know there's 4 days off for you guys. It's tempting.